Hey there, you wonderful third graders. Welcome to Math on BCPS-TV. However you're joining us today, whether it's on your television or through YouTube. Well, thank you for joining us. My name is Mr. Tang, and I will be going over week 6, lesson 1, solving two-step word problems, addition and subtraction. All right, so just like the title says, we will be solving and taking a look at two-step addition and subtraction word problems by using models and equations. So here's the thing, right? Word problems. We take a look at them, we groan, we go, oh, I don't want to do word problems. But why is it? Why is it that we don't like word problems? I think a lot of times as mathematicians, we don't take the time to slow down and think about the work that we're doing here. Let's approach today and think of yourself as a math detective. Okay? So think of yourself as somebody who is here to solve a problem, a mystery. We're solving mysteries. Okay. And so the thing here that we're dealing with, the two-step one, is that sometimes while solving this mystery, we don't have all the information that we need up front. So we need to do a little bit of digging. So let's think about that. What strategies have you been using to find a hidden question in story problems? Now, sometimes in word problems, a lot of the ones we've already seen, say like in second grade and maybe some beginning of this year, there may not be a hidden question. So for example, this question here is a one-step word problem where all of your information is laid out in front of you. That doesn't mean you don't take your time and read it again, because we still need to figure out what information we know and what information we're trying to figure out. So if Elena makes 3 trays of cookies, shout out to Elena, with 10 cookies on each tray, how many total cookies does she make? Straightforward here, right? 3 trays of cookies, 10 cookies each tray. What is the total amount? So I still broke that down, I read it again, and I pulled out my important pieces of information. I'm even visualizing it. I have 3 different trays. Each tray has 10 cookies. So in this instance, this is a one-step word problem that we can use addition to solve that. 10 plus 10 plus 10, right? Okay. So this is where it gets a little bit more tricky when I add on another question before asking you even to solve the first question. Elena makes 3 trays of cookies with 10 cookies on each tray. If she eats 20 of them, how many will be left? So the hidden question here is one that's not asked in the question itself. We'll come back to this one. So the next thing we want to do is take a look at solving our word problems using models and equations.
How can you use diagrams to solve two-step problems? Think about this question during the lesson. The results of a car survey are shown in the table. How many fewer cars in the survey have poor fuel efficiency than have either good or average fuel efficiency? Use estimation to check the answer.
Before I play the video anymore, I just wanted to reinforce the idea of rereading word problems. Think of yourself as a good mathematician slash math detective. In order for you to truly understand what you're solving, you have to understand what the problem is presenting to you. So here it says we have a survey, okay, showing fuel efficient cars. So a fuel efficient car means it's good on gas. Like that means like if you put a gallon of gas, it'll go a lot longer if it's good. It would go a lot less if it was poor. So if we're taking a look at this survey here, we see that 98 cars have good fuel efficiency, 165 have average, and 224 have poor. Okay, so we're taking that data in. Now let's reread the problem. How many fewer cars in the survey have poor fuel efficiency than have either good or average fuel efficiency? Okay, so this is going to be one of those questions with the hidden question. You're not going to be able to solve this from in one shot. There's going to be something else that you have to do first. Okay, so let's take a look at that.
Step 1. Find and answer the hidden question. How many total cars in the survey have either good or average fuel efficiency? Draw a bar diagram and use a letter to stand for the unknown quantity.
Okay, so our bar diagram is going to be used to combine two things. That line at the top is going to represent a total, and these two pieces here are going to represent the pieces that we're combining. So take a look at it. What are we going to be combining right now? How many total cars have either good or average? This wasn't part of the original question, but we need to be able to find this in order to answer the next part of it.
Use X to represent the unknown total. There are 98 cars with good fuel efficiency and 165 cars with average fuel efficiency. X equals 98 plus 165. 165 plus 98 equals 263. So, X equals 263. 263 cars have good or average fuel efficiency. What does the letter X represent in the bar diagram and in the equation?
So let's take a look at it. That letter X is the unknown total. Why do you think we used a letter to represent a number? It's because when we first looked at it, we weren't sure what that total was, right? So that was like it's our mystery variable that we have to try to figure out and solve for.
The letter X represents 98 plus 165, or the total number of cars with good or average fuel efficiency. Do you need to use X to represent this unknown quantity? Explain. No. Any letter or symbol can be used to represent the unknown quantity in Step 1 of the problem. Step 2. Use the answer to the hidden question to answer the original question. How many fewer cars in the survey have poor fuel efficiency? Use Y to represent the unknown difference. From Step 1, you know that there are 263 cars with good or average fuel efficiency. There are 224 cars with poor fuel efficiency. Y equals 263 minus 224. 263 minus 224 equals 39. So Y equals 39. 39 fewer cars have poor fuel efficiency.
Okay, so let's go ahead and review that. So we did have our hidden question, which was how many total cars make sense as far as being considered either good or average, right? So what did we do there? We combined the two pieces to get our total number of cars that were either good or average. And what equation does that look like? 98 plus 165. So that bar diagram shows us the part total. That total is an unknown, but when we add up the 98 and the 165, we did get 263. 263. And the difference means it's, so now we can actually solve our question now that we have that unknown piece, right? So 263 minus 224 is going to give us our leftover, which is what we're searching for, is that difference between the good and average and the poor.
Why is the letter Y instead of the letter X used to represent the unknown quantity in Step 2? The letter X was used to represent the unknown sum in Step 1. you are finding a different unknown quantity in step 2, so another letter or symbol is used.
You could have used any symbol or letter other than X.
Now you know how to use diagrams to solve two-step problems.
Okay, so that was a lot. There's a lot to take in, and as you can see, these word problems they require a little bit more attention. And I think when we look at it as a detective, if we're solving a mystery, we want to be able to think about all the clues that we have, right? We want to be able to think through all the pieces of information and make the most sense of it the best we can. So let's go back to the question with Elena. She makes 3 trays of cookies with 10 cookies on each tray. If she eats 20 of them, how many will be left? So right away, we can't use the information that we have to solve this. So there is that hidden question, right? So take a look at the question, take about a minute, and try to figure out if you can see that hidden question. What piece of information do we need to find out that we don't have? All right. So kind of like we started off with, we figured out how many cookies she has. So we says we have 3 trays of cookies with 10 cookies on each tray. So the first part of this would be figuring out if I have 3 different trays with 10 cookies on each one, kind of just like what we did with the bar diagram in the last problem. We want to figure out that total, right? So let's use C because, like the video said, it doesn't matter what letter we use. We're just using something to represent our total. So I'm using C for cookies. Who doesn't like cookies? And how many do we have? We can use addition to figure it out, right? And 10 plus 10 plus 10. So we know we have a total of 30 cookies. Now that we know we have 30 cookies, that was a hidden question. They didn't ask us how many total cookies there were, but we know we needed that information to solve this. So with the 30 cookies, I know I can subtract the 20 cookies because that's what we're doing when we're eating them. We're taking them away. So 30 minus 20, what are we left with? 10. So in your packet, there is going to be another example that you can read through if you need another look through to see how you can use different strategies, how you can read the problem, how you can figure out step by step how we can solve. The question has to do with Ariana and making money. So take some time, read through that question if you need to, another example for you. And then when you're ready to, here's some couple things for you to try. So the guided practice is for you to try as extra practice. So questions 1 and 2 on the guided practice on that first page. And then to turn into your teachers, you're going to be turning in the independent practice piece. So questions 3 and 4 on that same page. And when you're done with that, the next page is more practice and problem solving. That's just going to be some additional practice for you, which I know you're all dying to do. You're all ready to get out there and be the best math detective you can be. Well, I want to thank you so much for spending your time with me. And until next time, stay safe, wash your hands.